Welcome to a special deep dive tailored just for you into the Before AGI podcast. Today we're taking a fascinating look at how artificial intelligence is completely changing the world of logistics and supply chain management.
That's right. And forget those small incremental tweaks we might have seen in the past. What our sources highlight is a real fundamental shift in how things get where they need to go. It's moving from simply reacting to problems as they pop up.
Which was the old way, really.
Exactly. To actually seeing them coming and stopping them before they even happen. Proactive, not reactive.
Okay, let's unpack this then. We've gathered some really interesting material that shows exactly how AI is, making these waves. We're not just talking about finding slightly better routes for trucks anymore, right?
Far beyond that. This is about a total rethink, powered by the ability to predict what's next and automate so much of the process.
So our mission today is to pull out the most insightful pieces for you, the listener.
And what's truly remarkable, I think, is how far-reaching this is. The information we've looked at details AI's impact on everything from ensuring equipment stays in top shape.
Predictive maintenance, that area.
Precisely. All the way to accurately predicting what people will want to buy and then orchestrating the entire journey of those goods. It's end to end.
Okay, so we all have a basic idea of optimizing logistics, maybe using software. But what's the core difference AI brings to the table here?
Well, the fundamental change is this move toward proactive management. Like I said, traditionally, logistics relied heavily on looking at what already happened, using past data and fairly static models,
Looking backwards.
Right. Now, AI is bringing in live, up-to-the-minute information, making sophisticated forecasts, and even enabling systems to make decisions on their own, autonomously.
And you mentioned it's not just one company benefiting.
No, that's the interesting part. It's creating these knock-on effects, these synergistic benefits that help everyone involved in the supply chain: freight owners, forwarders, carriers, even the terminals.
Knock-on effects. Okay, could you give us a concrete example of that? How does that actually play out?
Sure. Imagine AI predicts a potential bottleneck, maybe congestion, at a major shipping port days in advance.
Yeah.
That information, shared in real time, can then inform the schedules of the ships heading there.
So they can adjust course or speed.
Potentially, yes. Or it informs the inventory planning of the companies whose goods are on those ships, so they know about delays. And it could even adjust the staffing levels needed at the port itself to handle the situation when it arises.
Ah, I see. It's a coordinated, intelligent response across the entire system.
Exactly. And what's exciting is the potential for significant improvements, quite tangible ones. Our sources point to possible reductions of around, say, 15% in fuel use, a 20% drop in vehicle downtime, which is huge for assets, and maybe a 25% increase in how efficiently deliveries are actually made.
Those are really significant improvements, not just small percentages. Let's dig into one of those areas then, keeping everything running smoothly. Equipment. How is AI changing maintenance?
Right. This is where predictive maintenance comes in. And it's a real game changer in how companies manage their assets. Big shift. Instead of just doing routine checkups based on time, or worse, fixing things only after they break.
The reactive approach.
Exactly. AI algorithms are constantly analyzing data coming from what are called IoT sensors, Internet of Things sensors.
Okay, what kind of data are we talking about?
Think of these as tiny connected devices attached to vehicles, warehouse machinery, engines, constantly feeding back information. Things like engine performance metrics, tire pressure, vibrations, temperature, oil quality. Loads of parameters.
So the machines themselves are telling us when they might need attention. It's like they're raising their hand.
Precisely. And it gets even smarter.
Yeah.
Machine learning algorithms look for subtle patterns in all that incoming sensor data. They combine it with historical maintenance records, how the equipment is actually being used day to day.
Usage patterns, yeah.
And they predict potential failures before they actually happen. Not just it might fail, but this specific component shows signs of where likely to cause failure within X days.
That level of detail.
Yes. And this is being built right into how entire fleets of vehicles or warehouses full of machinery are managed. So maintenance gets scheduled based on the actual real-time condition of the equipment, not just a date on a calendar or mileage marker.
That sounds incredibly efficient. Much less guesswork.
Yeah.
Are there real-world examples of this in action? Big companies doing this?
Oh, absolutely. Our sources are full of them. For example, FedEx is using predictive maintenance for their cargo aircraft, critical assets.
Makes sense for aircraft.
Definitely. Royce, who make aircraft engines, they reported a remarkable 75% reduction in inspection time for their engines using AI.
75%. That's huge.
It is. Amazon uses it extensively to keep their huge fleet of warehouse robots running smoothly, Caterpillar for their heavy construction equipment, GE for their jet engines, Shell for their complex oil and gas equipment. It's becoming quite widespread, especially in industries that rely on expensive, critical machinery.
A 75% reduction in inspection time? That's a massive saving in labor and downtime. What kind of overall impact does this have for a business, bottom line?
The benefits are substantial across the board, really. We're talking about potentially up to 50% less downtime for critical equipment. Think about the cost of a grounded plane or a stopped production line.
Huge costs.
Then there are maintenance cost savings. Could range from 10 to 40% compared to just reacting to breakdowns, and even an 8 to 12% saving over traditional calendar-based preventative maintenance.
So it's better than just scheduled maintenance, too.
Yes, because you're not fixing things that don't need fixing yet. Plus, it extends the lifespan of the equipment you catch problems earlier, and crucially, makes operations safer by preventing unexpected failures.
Okay, so AI is helping keep the physical assets running. What about predicting what those assets need to move, what things are needed in the first place? How is demand forecasting getting smarter?
Right, another major area. Traditional forecasting methods mostly look backward, analyzing past sales figures, simple extrapolation often.
Hoping the future looks like the past.
Pretty much. But that approach often misses the bigger picture, complex shifts in the market, emerging trends, unexpected events like, say, a pandemic or a social media trend going viral.
Things that weren't in last year's data.
Exactly. AI models, on the other hand, can take in and analyze a much wider array of information. Yes, past sales data is still important, but also current market trends, what people are saying on social media, competitor activities, weather patterns, economic indicators, even news events.
A huge amount of data.
A vast amount. And the AI finds those complex, often non-linear relationships and patterns that a human analyst or even traditional statistical models might completely miss.
It's like having a super-powered crystal ball for the market.
Well, maybe not quite crystal ball level, but significantly more powerful. And a branch of AI called deep learning, particularly something known as LSTM networks, long short-term memory networks.
Okay, LSTM.
Is proving very effective here. Think of LSTMs as a type of AI that's especially good at remembering patterns over long sequences of time. So perfect for understanding how sales trends might evolve. Combining these with other AI techniques, like variational autoencoders or VAEs with recurrent neural networks, is further boosting the accuracy of these forecasts. It's getting very sophisticated.
Where is this more intelligent forecasting being used most effectively?
It's becoming essential across the board, really. Retail, manufacturing, e-commerce, and naturally, logistics providers themselves. The big payoff is significantly improved inventory management, getting the right amount of stock in the right place at the right time.
Which impacts everything down the line.
Absolutely. Consider major players like Amazon and Walmart. They are really at the forefront of using AI for demand forecasting. It's core to their operations. We also saw examples like Spar Austria reporting over 90% forecast accuracy and a 15% reduction in costs by using AI. Specifically Microsoft Azure's tools.
90% accuracy, that's impressive.
It is. And Zara, the fashion retailer, also has a very sophisticated integrated AI system managing their demand and inventory in near real time.
So for us as consumers, better predictions mean fewer empty shelves, maybe faster delivery. And for businesses, less wasted stock, less capital tied up.
Exactly right. And the numbers really highlight the impact. We're seeing reports of accuracy improvements ranging from 10% to, in some cases, as much as 50% compared to older methods.
20% better.
And reductions in warehousing costs are often in the order of 5 to 10% just from having the inventory better aligned with actual demand.
Okay, so AI helps predict what's needed. Then it helps keep the equipment running to move it. What about actually handling the goods inside the warehouses themselves? What's happening there?
The warehouse is rapidly evolving into an intelligent hub. It's not just a big box anymore. AI and robotics are working together, hand in glove, you could say, to create automation that's not just faster, but also more accurate and much more adaptable than previous generations of automation.
Adaptable how?
Well, AI-controlled robots, like AMRs, autonomous mobile robots, can now navigate complex, dynamic warehouse layouts. They don't need fixed paths. They can figure out the most efficient routes to pick items, dynamically avoid obstacles like people or other robots, and even change their task priorities on the fly based on what's needed most urgently.
Well, so not the kind of fixed-track robots we might have imagined just a few years ago. Much more flexible.
Precisely. And it's not just about moving things around either. Smart inventory systems are becoming common. They often use computer vision, essentially, AI that can see and interpret images from cameras, along with RFID tags and machine learning algorithms.
To do what exactly?
To track every single item in the warehouse in real time, know exactly where it is. They can also optimize where items are stored to minimize travel time for picking.
Putting fast-moving items closer.
Things like that, yes. And they can even automatically suggest or trigger replenishment orders when stock levels get low for specific items.
And what about the actual process of getting items off the shelves and into boxes, picking and packing?
That's a huge focus. Picking and packing are traditionally very labor-intensive tasks, often the bottleneck in warehouse operations. Now we're seeing robots that use sophisticated computer vision and AI-powered grippers to precisely identify, pick up, and handle a wide variety of different items, even delicate or oddly shaped ones.
Handling different shapes and sizes used to be a big challenge for robots.
It really was. But AI is making huge strides there. And beyond individual tasks, AI is even starting to orchestrate the entire flow of work within a warehouse. It can dynamically allocate tasks to different robots and human workers, monitor progress, and identify any bottlenecks that are slowing things down in real time. Sort of like an air traffic controller for the warehouse floor.
That's a great analogy. Can you give us some real-world examples of these smart warehouses? Who's leading the charge?
Well, Amazon, again, is a leading example. They have hundreds of thousands of robots. I think the number was over 200,000 a while back, probably more, now operating in their fulfillment centers. Kiva systems initially, now others too.
Incredible scale.
It is. Then you have companies like Berkshire and Covariant, who are specifically focused on developing advanced robotic picking solutions, the really tricky part. Trax offers AI-powered systems that use computer vision for real-time inventory tracking on retail shelves, but similar tech applies in warehouses. And then you have the more established but increasingly AI-enhanced systems like ASRS automated storage and retrieval systems, and as I mentioned, those AMRs becoming increasingly common and smarter.
So things are moving much smarter inside the four walls of the warehouse. What about once the goods leave? How is transportation itself becoming more intelligent?
Yeah, the intelligence extends right out onto the road, the rails, the sea, the air. AI-powered route optimization is a key area here. It's no longer just about finding the shortest distance on a static map like we might use on our phones.
There's more to it.
Much more. These sophisticated systems use real-time data streams, GPS from vehicles, traffic sensor data, weather forecasts, even things like road closures or event schedules.
So it reacts to changing conditions.
Exactly. It dynamically adjusts routes as needed. Machine learning algorithms are used to predict traffic congestion patterns, sometimes hours in advance, and proactively find alternative, more efficient paths, avoiding the jam before you hit it.
That sounds like it could save a lot of time and, importantly, fuel.
Absolutely. Our sources indicate that improvements in delivery efficiency of around 25% are achievable through this dynamic AI-powered routing.
25%. Another big number.
Yep. Then you have intelligent load matching platforms. This tackles another big inefficiency in trucking, empty miles. AI is used to connect freight that needs to be shipped with available carriers much more effectively. It considers factors like current location, the specifics of the load, the type of vehicle needed, delivery windows, and even the past performance and reliability of the carrier.
Finding the best match, not just any match.
Right. This significantly reduces the number of trucks driving empty after dropping off a load, which is a huge win for carrier profitability, shipper costs, and of course, sustainability, less fuel wasted.
Makes sense. And what about those self-driving trucks we keep hearing about? Are they part of this picture yet?
They are definitely part of the picture, though maybe further out for widespread adoption. While fully autonomous vehicles, level 5 autonomy, are still largely under development and navigating complex regulatory hurdles.
Lots of testing still.
Lots of testing, yes. But AI is already playing a vital role today in advanced driver assistance systems, or ADSS. Think adaptive cruise control, lane keeping assist, automatic emergency braking. These improve safety and efficiency even with a human driver present.
Okay, so AI is assisting drivers now.
Correct. And yes, companies like Waymo, Google Spinoff, Too Simple, Embark, and others are actively testing fully driverless trucks, often on designated highway routes. It's progressing. We're even seeing AI used in less obvious places, like optimizing how cargo is loaded onto ships. P&O ferrymasters, for instance, used AI to figure out the best way to stack containers and vehicles on their vessels.
Maximizing space and stability, I guess.
Precisely, making transportation more efficient at literally every stage.
It really does feel like AI is weaving itself into every single link in the logistics chain. It's quite transformative. Looking ahead now, what's the next big thing? What's on the horizon for AI in logistics?
Well, the future holds some really exciting possibilities. Things that sound a bit sci-fi but are actively being worked on. We're starting to see serious exploration into the potential of quantum computing.
Quantum, wow. For what?
For tackling incredibly complex optimization problems that are just too hard for today's computers. Think planning the absolute most efficient routes for thousands of vehicles simultaneously across an entire country, considering every possible variable. Quantum might unlock that.
That's mind-bending complexity.
It is. We'll also likely see a rise in what are called hybrid AI systems.
Hybrid AI.
Yeah.
You mentioned that briefly. What does that mean in practice?
Think of it as combining the strengths of different AI techniques, getting the best of all worlds. So a system might use machine learning to predict customer demand, natural language processing AI that understands human language to understand customer inquiries about their shipments, maybe through chatbots or emails,
Okay.
and then use computer vision in the warehouse to ensure the right items are being picked and packed correctly, all working together in one integrated solution.
Creating a more comprehensive intelligence.
Exactly. We're also anticipating more collaborative supply chain intelligence. This is a big one. Using AI to help different organizations within a supply chain, the manufacturer, the shipper, the retailer, the logistics provider, share critical information securely and make smarter, coordinated decisions together.
Breaking down those data silos between companies.
Precisely. That could really smooth out a lot of the friction and inefficiency that often exists between different players in the chain.
That sounds potentially revolutionary. What else is coming down the pike?
Generative AI, the type of AI behind things like ChatGPT that can create content.
Right, everyone's talking about Gen AI.
Yes. It's being looked at for automating tasks like generating KPI reports, those key performance indicators businesses use to track success. Instead of analysts spending hours compiling data, Gen AI could potentially draft those reports. Then there's agentic AI.
Agentic.
Think of AI agents software programs with specific goals that can make autonomous decisions and take actions in real time based on the data they receive, without direct human command for every step. Maybe dynamically rerouting a shipment or adjusting warehouse priorities on their own.
More autonomy for the systems.
Yes. Digital twins are another area gaining traction. These are essentially highly detailed virtual replicas of physical logistics assets, like a specific warehouse, a distribution center, or even an entire supply chain network.
A virtual copy. For what purpose?
For running simulations, testing what-if scenarios, predicting potential issues like bottlenecks or equipment failures before they happen in the real world, and optimizing operations in a risk-free environment.
Like a flight simulator for logistics.
That's a good way to put it. And of course, we can definitely expect continued rapid progress in automation and robotics, smarter, more capable robots. Even greater visibility across supply chains thanks to the combination of AI and the Internet of Things. And a growing focus, rightly so, on using AI to make logistics more sustainable, optimizing routes for fuel, reducing waste, etc.
It sounds like logistics is becoming incredibly tailored and responsive, almost personalized.
Exactly. AI will enable hyper-personalization of logistics services, think delivery options tailored precisely to your individual needs and schedule. We'll see tighter integration with other advanced technologies like blockchain for secure tracking and 5G networks for faster communication with moving assets. There's a shift happening towards prescriptive analytics too.
Prescriptive.
Meaning AI not only predicts what will happen, predictive, but also recommends the best actions to take in response. Prescriptive, traffic is building on Route A, we recommend rerouting via Route B, which will save 15 minutes.
Giving actionable advice.
Yes. And even some really innovative applications are emerging, like using audio AI, analyzing the sounds machinery makes to predict maintenance needs, listening for problems.
Listening for failures.
Yeah.
Fascinating.
Oh.
Any predictions from industry watchers?
Yeah. Analysts like Gartner, for example, predict significant adoption of generative AI specifically for that KPI reporting use case within the next few years. And they also forecast a big increase in the use of smart robots, those AMRs, and advanced picking robots in logistics operations by around 2028. The pace is quickening.
This all sounds incredibly promising, almost utopian in some ways. But surely there are challenges in actually adopting all this new technology. It can't be easy.
Oh, absolutely not. Implementing AI in logistics isn't always straightforward. It comes with hurdles. Some of the key ones our sources highlighted include ensuring the quality, consistency, and reliability of the vast amounts of data that AI systems need to function effectively. Garbage in, garbage out still applies.
That equality is crucial.
Hugely. Then there's the challenge of integrating these new, sophisticated AI systems with older, often inflexible, legacy IT infrastructure that many companies still rely on.
Trying to connect old and new.
It can be tricky and expensive, which leads to another point. The often significant upfront costs of implementing AI solutions, software, hardware integration, training.
It requires investment.
Definitely. And there's currently a shortage of professionals who have the right blend of skills, both deep AI expertise and domain knowledge in logistics and supply chain management. Finding those people is tough.
The skills gap.
Yes. And finally, just overcoming organizational inertia and resistance to change, getting people comfortable with new ways of working, trusting the AI, that can be a significant human factor.
And any ethical considerations.
Good point. Yes, ethical considerations are important too. Things like potential bias baked into algorithms, maybe leading to unfair routing or resource allocation, and of course the ongoing discussion around job displacement as automation increases. These need careful attention and management.
Right. So bringing this all together, what does all of this mean for you, the learner, listening right now?
Well, I think the bottom line is that the way goods are made, stored, and moved around the world is undergoing a really profound transformation, and AI is right at the heart of it. From predicting when a specific truck engine part might need repair, to ensuring your online orders arrive at your doorstep as efficiently and, hopefully, as sustainably as possible, AI is the engine driving logistics to become faster, cheaper, and more reliable.
We've really only managed to scratch the surface of this vast topic today, haven't
Oh,
we?
absolutely. There are so many more layers we could explore: the specific types of machine learning algorithms being used, the economics of AI adoption, the broader strategic implications for global trade patterns. It's huge.
Indeed. What stands out to you most from this deep dive we've taken? What questions has it sparked in your mind as you think about how things get to you every day? We definitely encourage you to keep exploring these fascinating developments.
It's changing the world under our noses, really.
Thanks for joining us on this deep dive into the AI-powered future of logistics. For more insightful explorations into the world of AI and its impact across various industries, be sure to subscribe to the Before AGI podcast. And if you're looking to dive even deeper, perhaps with hands-on tutorials and further insights into the world of artificial intelligence, be sure to check out my YouTube channel, Ian Ochieng. That's Ochiengai. There's a whole world of AI out there to discover.